Welcome to AI Frontiers. Today, we explore the question, can machines truly innovate? Drawing from 45 recent papers in computer science artificial intelligence, we examine the cutting-edge breakthroughs, the limits of current AI capabilities, and the most pressing research themes. Join us as we investigate whether artificial intelligence is ready to invent entirely new algorithms and meet the innovators shaping the future of this dynamic field. A surprising gap in AI's abilities has emerged. Less than 40% of the time, even the most advanced large language models succeed in coding truly novel research ideas, as revealed by the ResearchCodeBench study led by Waugh and colleagues. Despite their extensive training and language mastery, these models often stumble when facing tasks that require genuine invention rather than mimicry. The frontier of artificial intelligence remains largely untamed, raising crucial questions about the future of machine-led research and the boundaries between imitation and creativity. Artificial intelligence is rapidly transforming the ways we work, learn, and create. In this edition, we examine 45 new papers that probe the very limits of machine intelligence. Central to this investigation is the question, can AI evolve into a genuine research partner, driving invention alongside humans? Our exploration covers key themes, including algorithmic invention, collaborative intelligence, safety, and efficiency. Join us as we navigate today's breakthroughs, challenges, and the overarching vision for the future of AI research. To understand the field, imagine computer science artificial intelligence, or cs.AI, as a vibrant metropolis in constant motion. In this living city, algorithms serve as the streets, data centers rise as skyscrapers, and the residents are intelligent systems, each with distinct strengths. Some excel in language, others in planning, assistance, or architectural design. cs.AI thrives on diversity, drawing from disciplines such as mathematics, neuroscience, linguistics, and engineering. This fusion not only powers modern innovations but also marks a shift. Large language models are moving AI beyond mere automation, positioning it as a true partner in human endeavors. The first major research theme focuses on large language models and agentic AI. Here, the central question is, can LLMs move beyond recalling knowledge to inventing and coding new research ideas? The ResearchCodeBench benchmark, introduced by Waugh and colleagues, rigorously tests whether these models can create state-of-the-art machine learning algorithms from scratch. This is akin to asking LLMs not just to pass tests, but to invent the tests themselves and grade them impartially. Benchmarking serves as a technical foundation, systematically measuring AI capability on truly novel tasks. The second theme highlights multimodal and embodied intelligence. AI systems are now capable of processing a diverse array of data, including images, audio, and even neural signals. For example, vision language models are enhancing educational technologies and geospatial analysis, while brain-computer interfaces are bridging the gap between human cognition and machine perception. This is analogous to a chef who leverages all available senses, taste, smell, and sound, to perfect a dish in real time. Multimodal representation learning underpins these advances, fusing varied data sources to enable deeper, more holistic understanding. The third core theme is trust, safety, and alignment. Ensuring that AI acts responsibly is paramount, especially as these systems are deployed in real-world, high-stakes environments. The MLA Trust benchmark, for instance, systematically evaluates agent safety within graphical user interfaces, where a single misstep can have significant consequences. This challenge is comparable to air traffic controllers working to avoid disasters. The technical challenge of alignment, ensuring that AI actions consistently reflect human values, remains central to advancing dependable AI. The research frontier is illustrated through a series of mini-stories highlighting both breakthroughs and ongoing limitations. The study by Waugh et al. Found that large language models succeeded in implementing novel research code only 37% of the time. Memory-augmented agents, capable of reflecting on past experiences, demonstrated improved learning by avoiding repeated errors. The GRESO framework enabled reinforcement learning agents to accelerate their learning by a factor of 2.4. Despite these gains, systematic compositionality, the flexible recombination of learned skills, remains elusive. The Coalesce framework showcased how agents can outsource tasks to peers, achieving up to 41% cost savings, a model reminiscent of collaborative business ecosystems. Turning to the standout contribution, ResearchCodeBench by Waugh and colleagues poses a foundational question. Can large language models invent and code new machine learning algorithms? The benchmark consists of 212 coding challenges derived from authentic 2024 and 2025 machine learning papers. Over 30 language models were evaluated, including leading systems from OpenAI and Google. Both automated checks and human expert reviews ensured methodological rigor. The overarching motivation is to assess whether AI can serve as a genuine research assistant, transcending simple mimicry. Examining the methods and results from ResearchCodeBench, the GEMINI 2.5 Pro Preview model achieved the highest success rate at 37.3%. The O3 High and O4 Mini High models followed with success rates of 32% and 31%, respectively. Common errors included misinterpreting new concepts and misusing software libraries. Notably, even when controlling for training data contamination, models continued to struggle with tasks demanding genuine novelty. These findings underscore the persistent difficulty of achieving true innovation with current state-of-the-art large language models. The implications of ResearchCodeBench are significant. Large language models demonstrate strong recall abilities but face persistent challenges in synthesizing and inventing new solutions. Most failures occur when tasks require combining multiple novel elements. This highlights the need for hybrid systems capable of deeper world modeling and flexible reasoning. The benchmark itself offers a robust platform for tracking improvements in AI capabilities over time. Importantly, the pursuit of these advances is driven by the broader goal of democratizing and accelerating scientific discovery. Looking forward, the vision for AI is one of agents equipped with internal world models and advanced foresight. The aspiration is to build safety and trust into these systems from the outset, enabling agents to learn, adapt, and collaborate as seamlessly as living organisms. The analogy compares today's incremental progress to scaffolding, with the promise of tomorrow's breakthroughs rising as skyscrapers. However, major challenges remain, particularly the unsolved problem of systematic compositionality, enabling AI to recombine skills with human-like flexibility. In summary, the story of artificial intelligence is still unfolding. Progress from mimicry to true innovation is underway, as reflected in key studies such as those by Waugh and collaborators. Collaboration, curiosity, and ethical considerations are crucial for guiding responsible advancement. Fundamental questions persist. Can AI ultimately invent, and what new obstacles will arise as technology evolves? Listeners are encouraged to join the ongoing discussion and contribute to the shaping of AI's next chapters. The content presented in this episode was synthesized through a combination of advanced AI tools and expert human oversight. Summaries were generated using the GPT 4.1 model, with text-to-speech synthesis provided by Google and visual assets produced through OpenAI's image generation technology. Human experts reviewed all content for clarity and accuracy, ensuring rigorous representation of the referenced literature, including key works by Waugh et al. As with any synthesis, some oversights may persist. Listeners are encouraged to engage critically and consult the original sources for further study. Thank you for joining AI Frontiers. If you enjoyed exploring today's groundbreaking research, subscribe for more in-depth analyses and daily updates. Join our community of explorers and innovators, and share your questions and insights in the comments. Be a part of tomorrow's AI breakthroughs by subscribing now. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.